So we started by looking at what AI is, and we said AI is the ability of a computer or machine to mimic human intelligence. So I'll show you a couple of things in Excel that will bring home this point. So one of the things we talked about was Excel Flash Fill. I said Excel Flash Fill acts like a lightweight AI feature that automatically detects patterns in your input data and fills in the rest for you. So while it's not a true AI, it is smart enough to guess your intent based on examples, then much like how AI will recognize patterns. So let me show you again how this works. So this is a table that captures information about customers and the amount they paid for a product. So you can see in this particular table that the products and the prices are mixed together, and here too, of course, domain name goes with the email. So for example, if you want to know the domain for each of these customers, so you could create a column called domain, and you can manually type multiply.com. So if you have thousands of emails, you can extract their domain names by typing them manually, but that's a lot of work to do. But however, there is an AI function, a lightweight function, which is called Flash Fill, that will detect what you're typing, what you're fetching out, and it will automatically fill in the rest for you. So I started by typing multiply.com, then I'm going to type the second one, mappy.cz. So now I could just go to data and I'll click on the next session, go to data and click on Flash Fill. So the system automatically extracts all the other domain names from this email and fill them out here for us. So what just happened? We trained it by giving it the first domain name, multiply.com, and we type the second one, mappy. This was gotten from this and this, and the system understands that, oh, this man wants to extract all his domain names from the email, so it fills the other one for us. So the same thing here again. These items are mixed up with the amount, so I'm going to extract the amount. So the first thing is I'll type the first amount, $500. Then I will type $507. Notice what just happened. So if I click on the third one and go to data, then click on Flash Fill, the system automatically fills in the rest for us. So it pulls out this and fills it off for us. So what we've just done is we gave it data, we showed it what we want, and it now understands our intent and now goes ahead to get our data for us. So you find these features in Excel 2016. So you either use go to data and click on Flash Fill, or you type Ctrl-E and it does that work for you. So let's go to a more simplified example about how AI really works. So in this example, we want to build an AI function that will be able to predict student exam success using Excel. So let's say you are a teacher and you want to predict whether students will pass or fail based on their performance. So this is how Excel will look at it. So we'll have the input data, that's where you have information about the students' scores and their performance, class attendance and all that. Then you have an algorithm. The algorithm is like a logic, your thinking pattern. Looking at the data, what you could reason out from the data that could be a way to predict student scores. In modeling, what you do is employing formulas to put your logic, your reasoning into practice, so that function will be able to calculate and predict exactly how the result will turn out. Then of course you have an output. Now if you recall, in the last class we talked about input data, algorithm, model and output, but I didn't put something on learn and improve. Learn and improve is also another section of AI. What this section basically does is it learns. For example, it's common to find that most of the predictions may not really come out as it should be. So you could have a prediction that is 100% correct, or 50% or 60%. So you could train AI, to become more smarter. So by training it, it learns, it will improve on what it does, then it goes back and until you're able to get a good result from what you're doing. So this is the table that we have. So we have students here, A to D, and this is their attendance, this is their scores, this is the homework, and this is how they pass. So looking at this data, So this becomes our input data. So we want to look at this data and come up with a way in which we'll be able to predict the behavior of these students and associated with success. So that takes us to the next section, which is the algorithm. This is the logic part. You can simulate a decision based on a rule. So let's look at a common sense here. Looking at this, you find that if a particular student attending the class more than at exactly 80 or more than 80%, and his scores is equal to or greater than 70%, is likely to pass. So if you look at that here, so look at what in the section for pass, you see that attendance was 95, test scores was 88, and the person scored 92. The second case here, attendance was 85, and test scores was 75, and homework was 80, and that made the person pass. So that led to this rule that if a student can attend a class at exactly 80% or more than 80% of the time and scores exactly 70 or above 70%, is likely to pass. So now this is our reasoning. So how do we now create a formula that will enable us to use this in Excel to predict results? So that we now move to the model part. This is so we're going to apply the rules. So while algorithm talks about the rules, it talks about decisions that we can draw from what we're looking at, the model part basically generates a function that puts that rules into a formula that we can test. So now in Excel, what we've just gotten here as our logic can be represented as what you're saying here. If this is greater than or equal to 8 and C2 is greater than or equal to 70, then you return pass, else you return fail. That is what this formula means. So once you test this in Excel, you will now see the result that we have. So let me show you how this will come out in Excel. So looking at this table, this was the original table data that we got, and this is our predicted result. So here, putting that in place, so if we come here and type equal to, this is the formula bar, equal to, if B is greater than or equal to 80% and C2 is greater than or equal to 70%, then you return pass. So once you do this and you draw it down, once you get the first result and you pull it down, it's going to return all this. So let's see. So you can see that exactly what we got as the pass rate and the failure rate is what is shown here. So that means that our prediction is 100% correct, and that's the right formula to use. So again, don't forget what I said. Assuming this did not give us exactly what we look for, we can go back, train, reason out, then go back and redesign, remodify our model in order to get something close to 100%. So that's how that section works. So if you just type this, let me just show you how this result was gotten. So I'll come here and type equal to if, bracket opens, and B2 is greater than or equal to 80, and C2 is greater than or equal to 70. Return pass, or else return fail. Then close this. We will just go back to the formula, then I will type pass, then here I will type fail. Then from here I will apply the same rule for others, so you can see that's how this result was gotten. So that's how you can use your AI to predict the result that will happen when students meet a particular condition. Okay, so we are also going to talk about regressional analysis. In using Excel regression analysis as an AI-like function means you are enabling Excel to learn relationship between variables and make predictions, a fundamental aspect of how AI works. So what you're going to see here is going to be strikingly different. Unlike the previous case that we had to think about our logic, then create a function, a formula to execute that logic. Here, the system will automatically give you the formula to use, and that is what you're going to use for your prediction. So regression in Excel models how independent variables inputs predict the dependent variable output, just like machine learning would do. So we're going to take this to Excel and see how we can employ regression analysis to enable us to generate the formula for this and of course predict it. So let me go there. So we've got our table here, right here. So now before we bring in regression analysis, we go to data and we check if we have data analysis. If you don't have data analysis here, what you're supposed to do is to go to File and you go to Options. From Options, you click on Add-ins, and from Add-ins, under Manage here, see Manage, you have Excel Add-ins. If you don't see Excel, just click here and pick Excel Add-ins. Then click Go. So once you've done that, just check on Analysis to Pack and click OK. Once you do that, then data analysis will automatically appear here. So now, if you go to data and click on data analysis, under data analysis, you see a lot of analysis tools. So we're going to use regression. So I'll click on regression. So what's our input range? So what's our input Y range? Our input Y range is the Y variables, the values we got from Y, and the input X range is the independent variable that we've got here. So let's go back again and get that done. So for you to get the dependent variable, you click once here, then go back from quantity sold up to the end. That becomes your input Y range. Then you click here, then select the two columns that you want to test if it has anything to do with the dependent variable. So that becomes, so you pick label, then select the output. Where do you want this output of the analysis output to be inserted into Excel? So I'll just click there. So what I'm going to do is I'll click once here, then I'll click here. I'm telling the system this is where I want the analysis to be inserted. Then I'll click OK. So once you click OK, the system will analyze it and it will bring out all the results you are seeing here. So now we're going to look at what this means and what are the results we're getting from here. Then we'll be able to look at these values that we have compared to the predicted values and see how close they are. So let's go through all this explanation. Regression analysis. Regression analysis is a set of statistical methods used to estimate relationship between a dependent variable, in this case quantity sold, and one or more independent variables, which is price and advertisement. It is a reliable method of identifying which variables have impact on a topic of interest. The process of performing a regression analysis allows you to confidently determine which factors matters most, which factors can be ignored, and how these factors influence each other. In this example, the dependent variable is the quantity sold, while the independent variables are the price and advertisement. So we want to see if the price and advertisement have anything to do with the amount we're using to sell. Then also, if it does, then we want to now tell the system to give us a formula that we can use to invest our values on and to see the kind of output, to predict the kind of output that will come out. So let's go to the first section. So here, there are certain variables here that are very important. The first one is R squared. So if you see here, you see that R squared is 0.9. This is quite close to 1. So what does this mean to us? R squared equals 0.9, which is very good. That represents 96% of the variation in quantity sold is explained by the independent variable price and advertisement. So the closer it is to 1, the better the regressional line fits the data. So if it was far below 0.5, then you would have discarded these two independent variables because they don't have anything to do with the result that we are getting at the quantity sold. Then another thing you need to watch out for here is significant F. So you can see that significant F is 0.0014. So to check if your results are reliable, statistically significant, look at significant F 0.001. if it is less than 0.05, you're okay. So if significant F is greater than 0.05, it's probably better to stop using those set of independent variables. That's another thing to watch out for. Then the third thing you need to note here is the formula that this has generated for us. So you can see here, intercept this plus in bracket price times minus 835 dot that plus advertisement times that. That's the formula. So the formula that the system has generated for us is Y, which is equal to quantity sold, which is equal to 8536.215 minus this times price plus 0.592 times advertisement. That's the formula the system has generated for us. So now what it means is, if this is the formula, then we can now check to see what will happen. Let's assume that we put in so if we put in a certain amount for advertisement, then what will be the quantity sold? We can just insert that and the system will tell us exactly what will happen. So now comparing the predictable value, so if you now use this formula to calculate all, fixing the values for the prices and the advertisement, then what you have, this is our actual, what you have will be this. So you can see while this one is 8523.0, this is 8500, quite close. If you look at this again, 4472, while this one is 47. So by the time you finish this, so the residuals is the difference. It's the difference between the actual minus the predicted value, and you can see how it is. So by the time you plot a graph on that, you see that it's almost it's quite close. So this formula is what the system has generated for us, and we can now use it to predict what we want to do. So now again, let me draw attention to something. If quantity sold is equal to this minus this times this plus this times this. So what that simply means is that the two variables we just need to play around with is the price and the advertisement. So if we inject a certain amount of money into advertisement and put our price at a particular rate, the system will now predict the possible number of quantity that we can sell. So this is how AI works, and you can see how it can be used in prediction. So thank you for listening.